In the last two videos, we explored the basics of LangGraph, how nodes represent logical units of work, and how the flow between them creates an AI reasoning pipeline. But until now, our examples worked with simple single message states. In this video, we're taking the next big step, moving towards structured states that carry multiple pieces of information together, just like an agent's memory. So think of state as a data package. It holds everything your graph needs to process, pass, and transform information at each step. We'll start with the code and then I'll try to explain the code accordingly. So let me create a new file here, complex graph.ipynb. First of all, from typing, import TypedDict and list. Let me run this and then select the kernel. So it's running from LangGraph dot graph import state graph comma start comma end. Okay, so these are the imports we will be needing. So the cell is running. Now I'm going to create a class that contains our state here. So class agent state, and then the type will be TypedDict. Inside this, I'll have a name, I'll have age, I'll also have skills, and then a result. So, unlike our previous video, instead of just one text, our now states contains multiple attributes like a person's name, age, and skills. After this, we'll be creating our nodes here. So for the first node, we're going to create a function. The parameter will be our agent state. And I'll write a docstring for this. This is the first node. And then here, I'm going to update my state here. So the result variable in the state will be updated. State name, welcome to the system. Then I will return the complete state here. Okay, so this is going to be my first node. Similarly, I'm going to type in the second node now, def second underscore node. Again, it will have a parameter of state. The node will always have the parameter of state, and then it will return the entire state here. Write a docstring. This is the second node. And after this, I'm going to update the state result again here. But first of all, I'm going to bring out my skills and then convert them from a list to a string. Dot join state skills. And finally, I'm going to update my result. So state result plus you have skills in state skills. And then again, I'm going to, let me just do skills here, not state skills, because I've already extracted my state skills from this. So again, I'm going to pass out the entire state here. Okay. So each node in this particular graph that you see here, or the graph that I'm going to build, reads these structured states and then does its task and then passes it forward, enriching it step by step. So the first node here acts like an initial greeter. It welcomes the person into the system. And then the second node that I have adds more context, like uh, like the skills that they have. And then uh, I'll also have a third node here. So what is that? Let me write down third node. Will contain an state, agent state again, and then it will return agent state for now. So let me write down, this is the third node. And then here what I'm going to do is I'm going to update my state equals to state result plus, let me add something more here. So in string, you are state age years old, and then end the string here. And then again I'm going to return the state. So the third node completes the flow by including the age, creating a full personalized summary here. So the data flows from one node to another, gradually building the final message, just like a well-organized thought process inside an AI agent. So now we'll build that particular graph. So let me run this. It's running. We'll define a state graph, and then inside it, I'll have agent state, Then I'm going to add my first node. First node will be first underscore node, comma. I will now define the function with that first node. Then I'll also have a second node similarly, and then the third node. Let me copy this down. This is going to be my second node. And then finally, I'll have my third node. So I'm going to add ages now. So first of all, we will go from start to our first node. Then we'll go from first node to second node. Then we'll go from graph.add underscore age, second node to third node, and then finally after third node, we'll go to end. Let me compile this. So let me write an object name bot equals to graph dot compile, and then print out the bot here or the graph here. So as we can see, it goes from start to first node to second node to third node, and then finally to the end. So the three simple nodes here highlights the true power of LangGraph. It helps you modularize reasoning, breaking large tasks into small, reusable logical units that form a clear and more traceable path of execution. So instead of handling everything in one complex step, LangGraph lets you think and build in stages, exactly like how agents reason in real life. So we'll complete this and then see the result here. So let me build my input state. I'll type out the name here. Name can be Alice. Age and skills can be this one here. So I don't need to pass in the result yet because that will be formed from within the nodes, and then I'm only going to pass until this skills here. So let me say data science. Okay, then finally what I can do is I can invoke the bot using this input state, and then finally print out my response. So my response will be printed. First of all, what will happen is it will go to this particular node here. So it will take our name and then it will say welcome to the system. With this entire message, it will add you have following skills, and then after that, along with this entire message, it will add the age of the person, and then we'll print the response. So let's see. Skills. Okay, what is it? Skills. What else here? Okay, here I've done some mistake, added an extra space. So let me run this again. And then as you can see, the result is Alice, welcome to the system. You have skills in Python, ML, and data science, and you are 30 years old. So based on the flow of data in between these nodes, the result had been updated, or basically some extra strings have been appended in each of these results here. So I hope you understood the code and then understood the concept of this multiple node that we have been implementing here. So far, we built a linear graph that processes structured input and composes a final result step by step, right? But this is just a beginning in LangGraph. In the upcoming video, we'll take this concept further by introducing branching logic, where your graph can make choices dynamically based on the state. So stay tuned, because from here, LangGraph will get very, very, very interesting. So if you like our content, do like and please subscribe so that we can bring up some more contents to you in the upcoming days. Until then, stay tuned.